Yes. Hey, welcome back. Now let us solve the problem. Merge for linked list. Yes. We have done for array and now we have to do it for linked list. So what is the question? You are given the pointer or reference to head of the linked list and your task is sort the linked list using merge sort. So first of all, let's get the most naive out of the let's get the most naive way out, and that is nothing but using something to solve the question, like using any given way to get the answer. The most naive way. So let's just get that out first. Just have error and I'll head exit. See, now your first aim should be to solve the question, not to get come up with the actual algorithm to do it. After that, let us see how we can solve it. Okay. So we'll do head dot data and go to the next one and then sort the array and then dummy is a node with value none and you'll have cur pointing to dummy and for I in ARR you'll do a new node which is nothing but node with the value of I and you'll set it to cur dot next and then you'll move the cur pointer and then what you will do, you'll return the dummy dot next. The most naive way to do it. Let's just see if it works or not. There's nothing special about this. I put hide over somewhere. Yeah, there's nothing special about this way to do it. This is the most cookie cutter way, and this should be capital N because that's how node you define. Yeah. So now we got the most cookie cutter way out. Let's see if it works or not. Yeah. This is the most cookie cutter way. Nothing special about this. Nothing what do you call intuitive about this. Nothing. So now what we will do? Now we will implement the actual merge sort algorithm. So first what we did was that we got the actual what you call solution out of not solution but solving the problem out of the way, which is the most important. Remember. So first thing to do is to do brute force or something or anything to solve the problem. First, now let's do merge sort. So how does merge sort actually work? So let's take the first array itself: 3, 5, 2, 4, and 1. So what you'll do, you'll break the array into two halves. So you'll have 3, 5, 2 in one half, and 4 and 1 in second half, and then you'll break it again. You'll have 3 and 5 in two halves, and you'll have 2, and then you'll have 4 and 1, and then you'll break it up again. So you'll have 3, 5, 2 and 4 and 1 will be sorted, so it will become 1 and 4. And so then what you will do, 3 and 5 will be sorted and then it will be combined, so you'll have 3, 5 and 2 and then 1 and 4 are actually sorted and then you will sort these three now. So what will happen is that you will get 2, 3, 5, 1, 4 and then you sort the entire thing because obviously there will be a space over here because they're not combined and then you'll have 1, 2, 3, 4, 5. So this has to be simulated in a linked list. So if you remember how actual merge sort works, so we would have the two parts, like we would have a break part and a merge part. In break part, we would just break the array in the middle, and then in the merge part, we would compare the arrays, like compare the elements and then sort it. So we'll do the same thing over here. And one thing is that we can't directly break linked list in the middle, like we can't get middle as length of the linked list divided by two. That is not possible. So what we have to do? We have to go back to our old friend, the tortoise and hare algorithm, and we will implement that. We'll get the middle, and we will make sure that in the middle itself, we will make sure to break the linked list also, that we don't have to do it afterwards. So what we will do? So let's first get out the main thing out of the way. So we will have a tortoise and hare. It's called Floyd virtual algorithm. So we'll call it Floyd. So you should have self over here, and then we'll be given the node. We'll have slow and fast as node, and you will have three pointing to none. So what will happen is that when you use Floyd-Warshall algorithm, your linked list will be break down in the form of 3, 5, 2, and then 4, 1. But you want the link between 2 and 4 to be broken also. That is why what we will do, you'll have a previous pointer which will actually be keeping track of previous things and it will break it. So what we'll do is that you'll have 3, 5 and one half and 2, 4, 1 and other half. and then we break the link between 3, 5 and 2, 4, 1. That's why we have a previous pointer. And so while path.next exists, so what we do, path is path.next dot next, and then we'll have slow is equal to slow dot next. But before that, we have to do three is equal to slow and slow is slow dot next. And then what we will do after doing everything, so slow dot next will break the link and then return the slow pointer. So what you did, you took the entire path, you broke the link between 3 and 5, and you return 2. Like you return pointer pointing to 2. So now what we'll do, we'll have the breaking part, self and the node you will have. So if there is no node or no node dot next, that means you don't have any node, or you're just given a single node, like you just have three over here. So you can't obviously apply the algorithm. So you'll directly return the node. Or else what we'll do, you will get middle as the float, float with the value of node. And then what you will do, so you have the left half in the form of node, you have the right half in the form of middle. So you will call the what do you call? You will call the same function again, self dot breaking on the left part, which is nothing but the node, and you'll call the self dot breaking on the right part, which is nothing but the middle. So now what you did, you not only broke it, but you are calling the merging functions just like in normal method, but breaking functions. But not what you have to do now, you have to merge it. So you will return self dot merge of the two broken parts. So now what you have to do? Now you have to fill the merge sort. And if you know how to merge two sorted arrays, then you can easily come up with the intuition for merging two sorted linked lists. So we'll call it merge. You will get head one and the head two, and then obviously we'll have self over here. So we'll have node with the value none. This is just a dummy node and curve pointing to node, and you will have C1 pointing to head one and C2 pointing to head two. And while C1 and C2 exist, so what you will do, if the C1 dot data is less than C2 dot data, then you will do C1 is equal to C1 dot next. But before that, curve dot next is equal to C1. Else you will do curve dot next is equal to C2 and C2 is equal to C2 dot next. And regardless of whatever you do, you will do curve is equal to curve dot next. So now what will happen is that there is a chance that C1 or C2 might still be left. It's not guaranteed that we will have exhausted both the linked list by now. So what we'll do is C1 exists, then curl dot next will be equal to C1. And if C2 exists, then curl dot next will be equal to C2. And then what we'll do, we'll just return the dummy dot next, dummy which is called as node dot next. Just compile and run it once. Oh, I forgot to call it over there. And same can't do like this, you have to do like this, and then you have to call breaking the head node. Now let's just compile and run it. Okay. BREAKING, 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 and Lord, I forgot to put self over here. Yeah, and it is working. Let's just submit it. And yeah, as I say, it works. And yeah, that's all for it for now. And thank you for watching and good luck.